In this lesson, we explore compound interest. Albert Einstein once said of compound interest, the most powerful force in the universe is compound interest. Benjamin Franklin says, money makes money, and the money that money makes more money. So in this lesson, we introduce compound interest, and we want to understand this powerful concept. Let's start with some important terms. Okay, investment. This is the use of money or capital for income or profit. A fixed investment. The amount invested as principal may be guaranteed. And let's pause right there. When we say the principal is guaranteed, that means you're going to get the principal back. It's guaranteed. And the interest is computed at a fixed rate. Examples include savings accounts, money market deposit accounts, or certificates of deposit. A variable investment, however, neither the principal nor the interest is guaranteed. Examples include stocks, mutual funds, or commercial bonds. Compound interest. This is interest that is computed on the principal, and any accumulated interest is called compound interest. Now get this. A bank computes the interest periodically and adds this interest to the original principal. The interest for the following period is computed by using the new principal. So in effect, the bank is computing interest on interest. Now what's really important to note is that in earlier lessons, we were talking about simple interest. Simple interest is calculated once for the period of a loan or investment. Using that formula, interest is equal to the principal times the rate times the time, PRT. But for compound interest, the interest is computed periodically, like maybe daily or quarterly. And this interest is then added to the original principal. This kind of interest is used at most banks for like savings accounts, for example. All right, in our first example, we have Mrs. Bond, who's a sales representative for Neutrogena. So Mrs. Bond receives a $5,000 bonus for reaching her annual sales quota, and she invests the $5,000 in a 1-year certificate of deposit, paying 3% interest, compounded quarterly. Determine the amount to which the $5,000 will grow in 1 year. So that amount we're calling capital A. Okay, now keep in mind that it says that the interest is compounded quarterly. Quarterly, that means for every 1/4 of the year, basically every 3 months. That's what quarterly means. Quarterly, so every quarter of the year. All right, so let's first calculate the amount of interest that she earns in the first quarter. All right, so watch this. All right, so we have this formula that calculates interest. Okay, and so the principal is $5,000. The rate is 3%, which is 0.03. And for time, it's a quarter. So it's 1/4, which you can write as 0.25 if you'd like. It's 1/4 of the year, right? Or 3 months out of 12 months, okay? Anyway, this is equal to $37.50 that Mrs. Bond earns in interest, okay? So her amount, I'm reading the problem, determine the amount to which the $5,000 will grow in 1 year. Now the amount after the first quarter is the initial $5,000 plus the amount of money that she's earned from interest. So after the first quarter, she has earned now, or she has a total amount of $5,037.50. Now, we're going to repeat this process for the second quarter, the third quarter, and the fourth quarter. All right, second quarter comes along. Let's figure out how much interest. Now, the new principal is $5,037.50, right? Not no longer the initial $5,000. The same rate, which is 3%, times the next quarter of the year, right? From the first time it was the interest was compounded, or the first time in the interest was computed, to now. So that's another 3 months, right? The next quarter of the year. And so what we have then is the amount of interest now is going to be $37.78. Now, this is more interest that was earned than from the first quarter, and that's because it's a higher principal. The rate hasn't changed. The time hasn't changed. What has changed is the principal. It's a higher principal value, so that means we're earning more interest. All right, so our amount that we have in our account, or Mrs. Bond really has in her account, it's not our account, $5,037.50 plus this new earned interest. He gives Mrs. Bond $5,075.28. That's like how much she has in her account now. Let's go to the third quarter. So for the third quarter, we have this new amount that she has, right? That she's has in her account. We have the rate, and instead of writing 1/4, I wrote 0.25, which is equivalent. So $38.06 is how much interest Mrs. Bond has earned in the third quarter. So now the amount in her account started at $5,000, has now grown to $5,075.28 plus $38.06. So the amount in her account after the third quarter is, I have $5,113.34. One more time, and this is for the fourth quarter. Let's do that one together. Now for the fourth quarter, notice that Mrs. Bond is earning $38.35. This is the most that she's earned in interest, and that's because this is the highest that the principal has been, right? So here comes the final answer. After 4 quarters, the amount in her account is $5,113.34 plus $38.35, bringing her initial investment of $5,000 to a grand total of $5,151.69 over a 1-year period that has the interest being compounded quarterly. So I hope this example shows the power of compounding interest. Honestly, if the interest was compounded one time, in other words, just using that simple interest formula just one time, instead of it being compounded quarterly, if the interest was just compounded once, Mrs. Bond would have earned less money. But because the interest is being compounded more frequently, she's actually earning more money. Now, of course, we don't want to have to do this 4 times, quarterly. Or imagine if the interest is compounded daily, right? You don't want to do this 365 times, right? And so there is a formula for compound interest. And it is the total amount that's in your account will be equal to the principal times 1 plus the rate over the rate divided by the number of compounding periods, which that's what n represents, to the power of n times t. So the thing I think I want to really lean into here is n. So for the previous example, when they said the interest was being compounded quarterly, n would be 4 in that context, okay, because there's 4 quarters in a year. If they say it's being compounded, let's say daily, then n is equal to 365. If they say that it's compounded semi-annually, then n is 2. So you're going to have to be very careful about what they tell you as far as the number of compounding periods. If they say monthly, then n is 12. Let's look at an example. All right, we have Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposit into this account, determine the amount in the savings account after 2 years. All right, let's do some labeling here. All right, so Kathy invested $3,000. That's your principal. Interest rate of 1.8%. That's the rate as a percentage. Compounded monthly. That's your n value. N is 12. And determine the amount in the savings account after 2 years. So there's your t. All right, so let's use the formula. So then A, which represents the amount that the money has accumulated to, is equal to P times 1 plus R over N to the power of NT. So this is $3,000 times 1 plus 0.018 divided by 12 to the power of 12 times 2. Okay? I'm going to do some simplifying here just a little bit before I use my calculator. So then this is 3,000 times 1 plus 0.018 divided by 12 to the power of 24. All right, I'm going to do a little bit more simplifying. My calculator tells me that 0.018 divided by 12 is 0.0015. And of course, adding 1 to that gives me 1.0015 raised to the power of 24. 1 to the power of 24, 1.0015 raised to the power of 24 is 1.0366279. And then that multiplied by 3,000 gives me 0.88. And then these are approximately equal. I'm rounding here. Once I got to this point here where I got 1.0366279, I eventually cut it off there because it kept going. So I'm saying approximately. And of course, we're talking about money. So we wanted to round to the nearest hundredth or the nearest cent. So the final answer, the total amount that's in the account after 2 years would be about $3,109.88. All right, here's a new example. We are being asked to calculate the interest on $750 at 4% compounded semi-annually for 8 years. So this is your principal, this is your rate, this is your n value, which is 2, and then your time. All right, so here's the formula again. The principal times 1 plus r over n to the power of nt. So this is $750 times 1 plus 0.04 divided by 2 to the power of 2 times 8. So then this is 750. I'm going to go ahead and evaluate this. 0.04 divided by 2 turns out to be 0.02, and then adding 1. So this is 1.02 to the power of 16. So my calculator will tell me that this is approximately $1,029.59. Again, I forgot to change this exactly equal to approximately equal to. We had a round. Okay? So this is not the final answer, because they didn't ask us like they did in the previous example. In the previous example, the question was determine the amount in the account. That's A. That's what A represents. This A right here. That's what A represents, the amount in the account. In this example, they're not asking us for that. They're asking us to find the interest. Well, if the investment was $750, if that's what your principal amount was, and it grew to $1,029.59, that means to find the interest, then all we have to do is take the amount that was earned in the account minus the principal, and that'll give us the amount of interest. So $1,029.59 minus $750 reveals that the amount of interest that was earned was $279.59. This is the final answer. So let's be very careful about answering the question correctly. Now, another very important concept and something that's super valuable is called present value. You may wonder about what amount of money you must deposit in an account today. Like, how much do I need to invest today in order to have a certain amount of money in the future? For example, if you're trying to save money to pay for like a child's college tuition or something like that in 4 years or whatever, how much do I need to deposit into an account today at a given rate of interest so that it will accumulate to $40,000 in 4 years or something like that, right? So this is called present value. Present value is the principal that would have to be invested now in order to reach your goal. And what we can do is our formula for compound interest, if we would solve that for P, so this is our formula, right, for compound interest, right? If we solve that for P, then we have a brand new formula for present value. So you would just divide both sides by this number here, 1 plus r over n to the power of nt. So in other words, this formula here leads me to present value, the amount of principal, is a divided by 1 plus r over n to the power of nt. This is the formula for present value. This is going to tell you how much you're going to have to invest today. All right, so let's look at an example now using this formula. All right, we have Sergio and his daughter. All right, Sergio would like his daughter to attend college in 6 years when she finishes high school. Sergio would like to invest enough money in a CD, a certificate of deposit, now to pay for his daughter's college expenses. If Sergio estimates that she will need $30,000 in 6 years, how much should he invest now in a CD that has a rate of 2.5% compounded quarterly? All right, so this is present value. This is how much do I need to invest today? Like what does my principal amount need to be? Okay, the formula is still on the screen. So P is equal to, A stands for the total amount that he's going to need. So, or she's going to need for college. So 30,000, it goes in for A, divided by 1 plus, now the rate is 2.5%. See if I can make a better plus sign here. Okay, the rate is 2.5%, which is 0.025, divided by, compounded quarterly means that n, the number of compounding periods, is 4 because there's 4 quarters in a year, to the power of n times t, 4 times. Now, t is 6 because it's in 6 years, right? This investment is going to be for 6 years. That's when she finishes high school. All right, so let's do some arithmetic here. So then this is 30,000 divided by, let's see. All right, let's do this. 0.025 divided by 4 is 0.00625, and then add 1 to that. So that's 1.00625, and that's being raised to the power of 24. Okay. So then this is equal to 30,000. Oh, I did it again. I'm sorry. I'm gonna have to approximate at this point, because I'm gonna have to round this number here. 1.00625 to the power of 24. I'm gonna round it to 1.1612920 to give me a final value of approximately $25,833.30. So this is how much Sergio is going to need to invest today at 2.5% compounded quarterly to have $30,000 in 6 years.